Hi everyone, welcome to another quick session. In this session, we will discuss digital signature, certificate authority. We have a lot of confusion around this topic. So, if you start exploring this topic, you may see a lot of explanation on the internet, but you might get confused. So, we will try our best to understand what digital signatures are and how it works in real time. So now let's get started. For instance, um, let me explain you as a layman example. So for instance, this is your sender. We can say this is a CEO of a company. So CEO company writes an email, right? So this is an email. Okay. The email content is hashed using a secure hash algorithm. So in this case, just assume that we have used SHA-256. So email content, this email content is hashed using SHA-256 algorithm. So the next step would be that the resulting hash, so this hash is encrypted with the private key. So hash encryption is done using by the private key, the sender private key, because this is a sender, as we know, this is the sender, and the content of email is hashed using a secure algorithm, for example, SHA-256, and the resulting hash, this is a resulting hash, right, is encrypted with the sender's, this is a sender's private key. The encrypted, now we need to remember, remember all these terms. So the encrypted hash is called a digital signature. So this encrypted, we can say this is a digital signature. So the encrypted hash is called the digital signature. Now the sender sends the original email content, right? The sender sends original email content. So this email content is always visible. So everyone can see it. So we are not going to encrypt the original content, right? So that we need to make sure. So when we talk about digital signature, so it means that we are not talking about confidentiality. We will discuss in a minute what it, a digital signature only make sure integrity, authenticity. It does not make sure the confidentiality, right? So email content could be a visible. It is a public thing, right? So anyone, I mean, it is, if you see that content, you can read through it, right? So it is visible. So the encrypted hash is called the digital signature. Again, the content of email is hashed using secure hash algorithm, right? So then the hash The hash itself, the resulting hash is encrypted with the sender private key. So now the sender sends the original email content. Email content is not encrypted, only the content of um, email is hashed, and then hash is encrypted. So the digital signatures. So the digital signatures are the resulting hash which is encrypted. These are the digital signatures. I think until here we are clear, right? So contain sender. So what this digital certificate? So this is digital certificate, and this is, let's say, digital certificate. So what this digital certificate contains? Digital certificate contains sender identity, contains sender's public ID, public key, not public ID, sorry, public key, is digital signed by trusted certificate authorities such as Digi Cert or Let's Encrypt. So you have acquired, as a sender, you have acquired the certificate from these authorities, right? So is digital signed by a trusted certificate authority such as Digi Cert or Let's Encrypt, right? So this certificate is also signed by certificate authorities. The certificate is obtained from a CA, usually purchased. So it is usually, let's say, purchased or issued by CAA. So again, three things. One, content of email is hashed using hash algorithm. The resulting hash is encrypted with the sender private key, which is called digital signature. And then the last thing is the digital certificate is signed by trusted certificate authority such as DigiCert or Let's Encrypt. There are multiple authorities out there, and the certificate is obtained from CA, usually purchased or issued. I think until this point things are clear. Now this receiver receives email, receivers email receives email, and receiver's email client first validate the certificate locally. This receiver will validate it locally. So I will explain you how it will validate certificate locally. So verifies the certificate chain. As we know that end entity certificate, right? The certificate which is attached. Then we have intermediate CA, and then we have root CA. So this is locally. This is locally available. Confirms. So this confirms the root CA exists in the system trust store, right? So verifies the certificate chain and entity certificate, and on top of that intermediate CA and then root CA. So first that certificate is verified through this chain and confirms the root CA exists in the system trust store. So the email client then performs an online revocation check. So first this locally check the certificate, right? And this is available in the system trust store, right? It is not online thing. It is locally available in your on your system. So when you acquire, let's say you have a company a system, then those all type of certificates are already installed, are already available on your operating system. So these all root CA exist in your system. So then the email, the last, when this locally check is performed, then email client then performs online revocation check whether this certificate is still available. It could be done uses OCSSP or CRL, certification revocation list. So it confirms the certificate has not been revoked. So this CRL can also be downloaded on your system. So root CA is not contacted online. So root CA resides on your system itself. Only this the certificate, the received certificate will be checked whether it is still valid. So receiver side, now signature verification. If the certificate is trusted, the email client extract. So in certificate, you have sender identity, you have the public key, right? Public key is also available. Also, hashing all algorithm information is available in this certificate, SHA-256. So the hashing algorithm which is used to uh, to hash email content, right? So that hashing algorithm is available in that certificate. Public key is available, right? Sender identity is available. So the email client extracts the sender public key from the certificate, right? And the public key is used to decrypt the digital signature. So these digital signature, right? Digital signature revealing the original hash. So you decrypt those digital signature and you calculate the original hash. The email client recalculates the hash of the received email content because you have that hash SHA-256, right? That information is available and that is done by the system itself, right? So as a user, you are not doing it manually. So using hash, recalculate the hash of the received email content using the hash algorithm specified the digital signature metadata. As we said, this is hash 256. So match message is authentic and unchanged. So that makes sure authenticity and as well as integrity. So this digital signature, assigning digital certificate, it makes sure integrity, authentication, and non-repudiation. So non-repudiation, that the person who has sent an email, he or she cannot deny whether he or she has sent an email. So it does not uh, make sure the confidentiality. So this is the whole process, right? So hash algorithm like this is a digital signature. So a digital signed email is verified by validating the sender certificate through a trusted CA, comparing messages, hashes using a sender public key to ensure authenticity and integrity. So that's it regarding this concept. I hope uh, I would be able to explain you in a simple way. I hope that will help you to understand what digital certificate is, what digital signatures are, and how email content is hashed how it is then decrypted with the sender public key. So these are important terms. We should know what root CA sits on your system, and the certificate is valid. It is checked by the intermediate CA and then root CA. So this hierarchy is this chain of trust is important, and the revocation list, whether this certificate is still valid or it has been expired. So I think that is sufficient for the CISSP exam. If you have any feedback or question, please share in the feedback section.